Hey, ladies and gentlemen, boys and girls, welcome to my YouTube channel. Guys, this is another episode on the Incredible Academics YouTube channel, and we're looking at the convergence of geometric series. I hope you guys enjoyed your Christmas. When we're recording this video, the date is the 27th of December 2023. Right, so the year is almost over, and I'm sure you guys are getting ready, to cross over. But anyway, let's get right into it. The convergence of a geometric series. What we're going to be looking at here is basically different values of r. Okay, so we're going to be studying the r of the geometric series. Okay, so there's a specific values of r that will make the series to converge. But let's start off by defining what it means to converge. What does it mean when we say a series converges? Okay. For instance, let's look at this series here. The sum of 5 into 1 over 2 to the exponent what? To the exponent n minus 1. Okay, so let's say it runs from n is equal to 1 up to infinity. Okay, in other words, it goes on forever. Do you understand? Right, and then we want to know if it converges. Now, convergence, is simply about whether it reaches, like, there's a ceiling, right? In other words, a perfect example is when there's someone who's jumping. Let's say this is you, and there's a ceiling up there, right? You keep on jumping up. Right, you keep on jumping up, so you find that when you're jumping for the first time, you get to this height. For the second time, you get to that height. The third time, to that height. Fourth time, to that height. Right. So, and then eventually you start hitting a plateau. In other words, you are jumping, but there's a point that you seem to be reaching, but you're not hitting, right? And that is the ceiling. So sometimes it's a ceiling, sometimes it's the floor, right? With the floor, obviously, it's when let's say there's something that you're trying to throw down, but as when you throw it down, there's something pushing it up. In other words, it comes down, but it gets to a certain point where it cannot go down any further. In other words, there's some sort of resistance. The same way when you're jumping up, something is bringing you down. It's like when there's gravity in reverse. Do you understand? So that is convergence, because remember, you could be reaching a particular value there, that is your maximum, or there could be a certain value which is like the minimum. I don't know if that makes sense. So convergence is a question of whether do we have a specific value that we are approaching but we're not exactly reaching. Okay, for instance, if you look at this series over here, you'll realize that the first term is going to be just 5, followed by 5 over 2, right? Followed by what? Number 3, followed by 5 over 4. And you can see that from here to there, we're actually decreasing. Do you understand? So now when a series is a decreasing a series, right? There's going to be a value that it approaches, but it never reaches. Do you understand? Sometimes you find that it's an increasing series, there's, as when it increases, there's a value that it approaches, but it never reaches. In other words, it's converging. But then there's a series whereby we realize that it's just 5 plus let's say 25 plus 125, like it keeps on going on like that. You can see that from 5 to 25 we've actually from 5 to 25 to 125 there's actually been an increase in value. Do you understand? So this is an increasing series, understand? But if you look at it, we're not sure what value it's going to reach, right? We're not sure if there's going to be a ceiling. Do you understand? So you'll find that it will keep on expanding. There will never be such a thing that this will expand, but it will never be more than 1. This will shrink, but it will never go below this value. So in other words, it's not reaching any specific value that we can say, this is the ceiling, or this is the floor. Do you understand? And those type of sequences which expand exponentially, right? We call them divergent. In other words, it keeps on increasing. It's not approaching any specific value. So these ones, they diverge. Okay? But if it's reaching a specific value, it converges. So to converge, to reach a certain value, in other words, whatever series that we're looking at, it tends to reach a specific value. Okay, and then to diverge, right, it's the opposite. To not reach any specific value. In other words, this one keeps on expanding and expanding and expanding. There's no limits to the terms of that series, right? It keeps on expanding. That's what we call a divergent series. So it diverges, and then we call it divergent. Okay. So I know you guys are still a bit lost, but the nice thing about math is that you don't need to dwell much on the theory, right? We are going to be focusing on what we call the some mathematical conditions. Okay, so there's mathematical conditions that we are going to focus on that will sort of like enable us to identify as to whether a series is convergent or divergent. Okay, so if the value of r is between -1 and 1, therefore the series is convergent, or it converges. Okay, so in other words, let me just try adjusting this a little bit. Seems like there isn't much space, not much space. Someone is calling me. Sorry about that, guys. There's someone who's calling me now, but so yes, let's carry on. So convergent, it converges, right? -1 between -1 and anything else. So in other words, you're going to look at the sequence. You're going to look at the series, and then you're going to then check if your r lies within this. So r is an element. I know some people, they like set bold annotation. You see, that's why I don't recommend this kind of notation, because you're always going to have issues with the brackets, whether it's square brackets or curly brackets. Okay, so r is an element of -1 and 1, so it's between -1 and 1. Okay, it's not equal to -1, it's not equal to 1, it's between -1 and 1. So that's that. So now, whenever you're given a thing, whenever you're given a series, you're just going to check, okay, what does the r look like? Okay, can you see that the r here is 1/2? Does 1/2 lie within -1 and 1? And if the answer is yes, then this converges. Right? So we're going to look at a couple of examples. And now let's say we've got this series here. Okay, the sum of let's say 5, and then into 3 to the exponent n-1. So n equals to 1 to infinity. In other words, this goes on forever. Does this converge or does it diverge? Okay, so basically what we're asking you here is, does this lie between -1 and 1 or not? And if the answer is yes, then it converges, and if the answer is no, then it diverges. So this is clearly outside this interval, -1 and 1. So this series is going to diverge. Okay, it's going to diverge. Right, and now let's look at this one. The sum of when n is equals to 1 to infinity of 6 into -1 is to n-1. n-1. Right? Does this diverge or converge? Now this is a tricky one, because you find that people think that 1 is actually within the interval, whereas it's not. I mean -1. So -1 is outside the interval. That's why we've got curly brackets, not square brackets. So the r does not fall within that interval. So this diverges. It diverges. So same goes for when there's +1. If we had +1 there, we'll still have the same situation, because +1 is not within the interval. Right? It's outside the interval because of the curly brackets. If it was square brackets, then we'd say, okay, 1 actually forms part of the interval, then the series converges. Okay, so we have covered the basics about the convergence and divergence of series, right? And then I'm just going to give you guys a couple of examples so that you can sort of like test yourselves. So let's look at this series n is equals to 1 to infinity of what? Let's say we've got 1/2 into -4 to the exponent n. Okay, so yes, -4 to the exponent n. And then let's also look at another one, the sum when n is equals to 1 to infinity of let's say 3/4, and then let's just say it's 1/2, 2/, let's just say 5/6 to the exponent n-1. Okay, right, that's the second question. And then the third one, n is equals to 1 up to infinity of let's say we've got 18 into minus 6 over 5 to the exponent n minus 1. Should we look for another one? The sum when n is equals to 1 to infinity of let's say 100 into let's just say 9 over 4 to the exponent n minus 1. Okay, so you just need to write diverges, converges, diverges, so on and so forth. So the first one, this is outside the interval, minus 1 and 1, so the r is outside the interval, so this diverges. Sorry. Why? Because minus 4 is not an element of minus 1 and 1. Okay, and 5 over 6 is an element of minus 1 and 1. In other words, it falls within the interval, so this converges. It does converge. Okay, and then let's check. Minus 6 over 5 is not an element of minus 1 and 1. In other words, this does not fall within the interval, so this diverges. So we're basically just checking the r against our interval, which is minus 1 and 1. So this diverges, right? It diverges. So that's it, ladies and gentlemen, and I hope you guys enjoyed the lesson. Until next time, peace out. Don't forget to like, subscribe, and share with friends and family. Peace.